Good morning and welcome. Thank you for joining this series with TEAP, the Search-Based Planning Lab, Robowitz, the RI Summer Scholars Program, and our special guests from the Community College of Allegheny County. I'd like to welcome Bill Fiedler from TEAP to tell us a little bit about the series and the motivation behind connecting today.
Good morning, everybody. My name is Bill Fiedler. I am the Region 2 TEAP director. So that means that I'm kind of in charge of Allegheny County, Fayette, Greene, Washington, um, and organizing events. And so this is one of those things that we've been trying to do to kind of connect teachers together. Um, TEAP has been around since 1952, and the idea is to to help promote technology and connect everybody together to advance the profession. And in the last couple of years, in particular, we've changed our the dynamic somewhat, and so we moved through these webinars, and so this particular series that we've been working on, I worked on. Um, the Robot Doctor program with Rachel and Max back at the beginning of the school year, and this is kind of developed out of that. And I thought the program was really good that they had, and the connections that we can make, I think, would benefit quite a few people. And so, using TEAP as an outlet to kind of help get that information out to everybody, I thought would be really a great thing. And Rachel has been exceptional in helping like promote this and get it out to everyone. So, anyway, I hope you all enjoy it. And we have third session coming up in July, so make sure keep an eye out for that. And if you, it's on the TEAP website, uh, teep.org. You can go to the website and register for the July session. So anyway, thanks for coming, and we'll have some questions and chance for some comments and things about TEAP a little bit later on today.
Okay, thanks so much, Bill. So we'll go ahead and we'll talk about today. We're going to go through and we'll have a chance to talk about TEAP. This session is being recorded and shared out with the TEAP membership across Pennsylvania. We're going to explore the Robot Doctor materials, and Bill mentioned that this is a educational series that was created in collaboration with WQED, the Pennsylvania Broad PBS system, Pennsylvania Department of Education, strong partnership with PA Rural Robotics, and a number of others to make those materials available to teachers and students. And we're delighted to have our colleagues from CCAC join us today, Patricia Thompson, Justin Starr, to talk about some of the opportunities that CCAC has to offer, specifically around mechatronics and data analytics. So in this field, what are some of the opportunities? And it's so often that we're trying to piece things together and we don't yet have a full roadmap for students or teachers. How do you find information? And so often many of us are searching for these materials. So I'm gonna pause. So I'm delighted to have a few minutes to share with you the Robot Doctor, and to talk about this set of series of resources and also some professional development opportunities that are upcoming. The Robot Doctor, at its core, there's a series of videos, and those videos were created in partnership with WQED, Robowitz, and Pennsylvania Rural Robotics. There were so many individuals that came together to create this series of resources during the pandemic. So it was a product of the pandemic. We know that during COVID-19 school closures, inequities, lack of access was really highlighted, and there's been some long-standing barriers within our communities. So we're working to create opportunities to link together and to understand what are some of those future careers and what are some of the pathways that students can take, and what are the professional development opportunities for teachers. And we think that TEAP is a huge part of creating that opportunity of understanding what possibilities are. So there's a series of 8 different episodes. These are available online. They were specifically created so that they're not tied to any hardware. So they're hardware agnostic. The series does not teach robotics, but instead inspires, draws upon robotics, and really focuses in to reinforce the relevancy of mathematics. So the series, all of the resources can be streamed, they can be downloaded, and they're available for free. There are 8 different sessions. There you can get it from the RoboWits website and from WQED as well. So it was set up very specifically to be able to also be loaded onto other devices if we're operating in situations where we don't have robust internet. And that can be in a number of our communities where they just don't have access to that all of the time. So Robot Doctor. There are 8 14-minute student video lessons, and they focus on giving examples of robots and the math behind that, tying it back to the classroom content. I think the team did a wonderful job of translating that, bringing that and making real world examples. Often we'll see things like robotics, or we'll hear about artificial intelligence, and it seems like careers or areas of study that are inaccessible to many of us. And this series is specifically trying to inspire and connect. There are student activity sheets that go along with the Robot Doctor series, and those are available from the website currently in 2 languages. Most of the resources will be available primarily in English. We've also created an ongoing series of professional development. As Bill mentioned, he was a member of one of those sessions in the fall called the Pioneers, where we came together and explored the Robot Doctor materials to see how they could be integrated into the classroom, how they could be integrated into after-school environments to inspire and work with students. This is about expanding pathways. So why are we looking at robotics? Why is computer science, why are robotics, artificial intelligence, why are these fields so important? Well, there's so many opportunities in the future for our students. And we know that if students don't have a strong foundation in mathematics, that many of the STEM fields will be close to them without remedy. So this series, The Robot Doctor, provides concrete examples for students why math matters, and it gives them, reinforces those concepts. We're trying to create awareness of STEM careers and opportunities, and really decrease that perception that STEM careers are inaccessible to many of us. So why are math and tech critical? Why are we spending so much time as a community, as a nation, looking at technology? Well, tech is now the world's largest industry. The growth in the tech sector is huge. And the Bureau of Labor Statistics calls this sector would fall under computer and information technology occupations. The average salary is twice that of all other sectors. So when we think about this area and opening doors and creating pathways for our students, it is critical. So what does a strong foundation at the high school level in math and exposure and understanding of future possibilities mean? It means growth, opportunity, and security for students, for their future families, and also for our communities as well. And the Robot Doctor is a series of resources that can be integrated into a number of learning environments, both connected and in person, can be used with hardware or independently. So I'd like to welcome my colleague, Dr. Maxim Lekachev, Max, to talk a little bit further about this resource.
All right, thank you, Rachel. Let me switch the screen a second. All right. Hi, everyone. So my name is Max Likachev, and Rachel, I think, already kind of gave a wonderful explanation of what the Robot Doctor series is and its motivation and so on. I'm just going to play a few snippets from some of those episodes to give a better context, kind of at the lower level, explain how it works. So as Rachel said, there are kind of two main goals behind the Robot Doctor. Number one is motivate and reinforce math concepts, in particular using just high school mathematics and show how it's being utilized in the context of robotics. And then the second one is really we would like to lower the perceived barriers in pursuing STEM careers to show that the math that you learn in high school is exactly the math that you should take when you study fields like robotics. So there are 8 episodes, and each one of 14 minutes. The host of the Robot Doctor is John Batsky, who is a graduate from Carnegie Mellon University, in particular from my lab. So it starts out as this. So every episode starts out as following. So let me play that.
My name is Dr. Jonathan Butsky. I'm not a medical doctor. Instead, I'm a robot doctor.
So this is a beginning of every single episode, and there are 8 episodes, and the first few kind of at a very accessible level, in the sense that they don't even involve mathematics. They just talk about the robotics, giving an overview of what type of robots there are, what are the elements that go into the design of a robot, and the overall infrastructure or the overall architecture of how robot brains work, in a sense that they need to sense the world, they need to decide what they're going to do next, and then they're going to execute the next action and then repeat. So that's called sense, plan, and act framework. So those lessons are really accessible to even middle school students. The next 6 get more into math, and today I will play some snippets out of the lecture 103, so lesson 103, and particularly on robot measurements. But in general, the robot measurements is the lightest one in terms of math. It really talks about different units and so on, and how different measurements are being done in a robot, what type of sensors they use, and angle measurements, metric measurements, and so on and so on. The lesson 104 is about robot localization. This is all about how does a robot know where it is in the world. And for each lesson, we have a supplemental material that explicitly talks about how that lesson maps onto particular topics of math. So like robot localization, for example, maps onto things like equation of a circle, system of linear equations, and so on. Lesson 104 is about robot motion. So how does a robot move? How does it compute its speed, distances, and it translates to some of these concepts, including some of the math from basic trigonometry and so on. The lesson 106 is robot vision, which is explains the cameras and the utilization of cameras, stereo cameras in a robot. It once again translates into system of linear equations and a number of related items. Robot sensing, lesson 107. This is about how does a robot build a map around it, so that it afterwards decides based on this map how to navigate to different places in the world. And it gets a little bit into statistics and probability. It also talks about laser sensors, how they work. And then the last one, lesson 108. So the 8th lesson is on robot controls. which is given a trajectory that the robot needs to follow, like a path that it needs to follow. How does it do it? And on the mathematics side of things, it talks about vector algebra and how you can use it to decide how to follow a curve. So the kind of, just to summarize, with the exception of the first 2 lessons, the rest of the lessons, the remaining 6 lessons are utilizing quite a bit of high school math. And on the robotics side of things, they explain effectively all the basic fundamentals, all the basic blocks of robot software architecture. In particular, how does a robot measure things? How does it know where it is in the world? How does it sense the world? How does it see the world? And how does it move? And how does it follow a curve? And each one of those topics maps onto several topics within math. And we have a supplemental material that provides that mapping, and we have some, and we're also working on additional material that explicitly talk about kind of in the context of math standards. So let me play a few snippets from the lesson 103 on the robot measurements. So this is the beginning.
Robot needs to be able to measure things, distances, size, angles, time, and other things.
Can you guys hear the
We'll
audio?
explore all that in this lesson. You'll need to rely on the math you already know, geometry, trigonometry, algebra, and some concepts from physics. But be prepared to take notes. Over the next 13 minutes, we'll discuss how robots measure. We'll look at how robots determine distances, how they measure angles, and how they measure time.
So each episode, including this one, ranges in its complexity from a very, very basic concept to a bit more advanced concept. And each episode finishes up with a set of a few questions that are take-home questions that can be solved by pen and pencil. So here is a snippet from this episode, which is kind of on a basic level. In particular, it talks about the small objects and the typical measurements for those, and it motivates it with the use of nanorobots, like tiny, tiny robots.
And believe it or not, there are nanorobots. They're named because they are very, very small. These robots are used in medicine, where they are injected into your veins, travel through your body to your heart, where they can monitor, clean, or fix damaged portions.
So very motivating, pretty creepy though. But anyway, so those are the nanorobots. And of course, once again, this is kind of at a very, one of the most basic concepts. Now on the a little bit more advanced concept within this particular segment is an explanation of speed. What is the concept of speed and how it's being used? This kind of gives you a sense for some of more advanced concepts, how they're being explained in the series.
Another place that speeds show up is when a robot is trying to figure out how far away an object is. A common sensor for measuring this is the LiDAR. The LiDAR is like a radar, except for it uses infrared light instead of radio waves. LiDAR works by transmitting a pulse of light. Light in air travels 3 times 10 to the 8th meters per second. In other words, it travels 300 million meters every second, or 300,000 kilometers per second, which is the same as 186,000 miles per second. The sensor times how long it takes the light to travel out to an object, then bounce off and return back to the sensor. Since light travels very fast, the time for this trip is very short. In fact, it is usually measured in nanoseconds, billionths of a second. There are 1 billion nanoseconds in a second, or 1 times 10 to the negative 9th seconds per nanosecond. Let's look at an example. Our robot is sitting outside looking at an obstacle. It uses its LiDAR to get a range to a nearby obstacle, in this case a tree. It gets a reflection back from the tree after 30 nanoseconds. That's our measurement of time. But how far away is the tree? We know that speed is equal to the distance divided by the time. We can rearrange this equation to show that distance is equal to speed multiplied by time. Since we know the speed of light is 3 times 10 to the 8th meters per second in air, and we were told that the time was 30 nanoseconds, we can multiply these two terms to get our distance. A nanosecond is 1 times 10 to the negative 9th power, and we can rearrange to get our units all together and cancel out the seconds, then multiply the numbers and simplify to get our total distance of 9 meters.
So you can see that, like, even from this short snippet, that it involves a number of concepts. It kind of primarily focuses on the concept of speed and how it's being utilized in processing information from LiDAR. But then also there are concepts that are related to, let's say, speed of light and use of units, measurements, and so on. So kind of for each episode, as I said, there is a mapping in terms of what the math concept it involves, and based on the classes that you teach, you may utilize certain episodes or certain parts of episodes. As I also mentioned, each episode ends with take-home questions. Those are meant to be something that can be done purely using pen and pencil. So once again, no hardware involved. And here is an example that for this specific episode.
This week's challenge questions are: if we had a robot with a sonar sensor, how long would it take us to get the return pulse or echo from an object? We know the object is 10 meters away, and we know that the speed of sound in air is 343 meters per second. Again, if we know an object is 10 meters away and the speed of sound is 343 meters per second, how long will it take to get the return echo?
So while the episodes have take-home questions, educators also have access to answers. They also have access to supplemental material that get into the explanation of how those answers were derived. And we're also working on additional questions that the educators can ask for each episode. So kind of any educator that would like to utilize the Roboductor material, get access to a lot of additional supplemental material that they can utilize and improvise on the use of the Roboductor within their classes. This is the slide that you already seen, but basically, as I said before, the first two episodes, they don't involve math and accessible to a wide spectrum of levels. It also kind of, we personally utilize it a number of times in the context of kind of giving classes on career and so on in robotics, so it's very accessible. And then the other 6 episodes, they do explicitly involve math and kind of are meant to be to illustrate the use of math in robotics. So with that, I'll stop and I'll let Rachel take over.
Okay, wonderful. Thank you so much, Max. We'd like to welcome our colleagues from the Community College of Allegheny County to share Trish Thompson and Justin Starr to introduce their team and some of the programs that they have on mechatronics and data analytics and how they're working with teachers and students in this area. So welcome, Trish and Justin. Glad to have you.
Hi, guys. Thanks for having us. This is so exciting. Let me share my screen and talk through a couple things. First of all, man, really cool stuff. I wish when I was working at a robotics company, I had the nerve to call myself robot doctor, right? That would be kind of fun, but I never did. But man, what a great resource. So, we were so excited to come talk to you guys about CCAC and some of our programs. So before I jump into that, it's myself and a colleague here. I'm Justin Starr. I work very closely with our mechatronics program at the West Hills Center. I'm an assistant professor at CCAC, and my colleague Patricia Thompson is on as well. She heads up really everything to do with our engineering technologies programs, which are offered at South Campus and the West Hills Center. So if you have any questions at all about anything we're going to share, just let us know and I'll put contact information up. We're just excited to work with you guys. That's the bottom line. We're always looking to collaborate. We believe strongly in the idea that robots should be accessible, and that's what sort of drove this. So I have more slides here in this deck that I'm going to go through, but I'm hoping Rachel will be able to share it as a reference afterwards. Just if anything in here jogs anyone's mind or anything like that. So at CCAC, we have essentially one department, which is home to our applied sciences. It's called Engineering Science and Mechatronics Technology. And that includes all of our programs, which could be related to robotics in any way, right? Civil engineering, CAD, electronics, mechatronics, polymers, nanofab, all that stuff is lumped in together. And I think it's important to recognize that at CCAC, we've come to believe that robotics is one of those skills that, yes, it's interesting to have it in a focused program like mechatronics, but we're seeing robots in civil engineering doing pipeline inspections. We're seeing robots in polymers doing manufacturing processes. We're seeing nano robots doing some interesting work. So it's sort of integrated throughout, all of our programs. And that's the idea. I think some people think that you go to CCAC and you think about engineering, technology, or mechatronics, it's kind of the VOTech plus track, right? And I don't want to dissuade that, but I want to say that we're more than just that offering, right? Students who come to CCAC, if we look at those who are enrolled in our program, it's about a 50-50 breakdown for what their goals are. Half of our students come from the VOTech track in high school. They're not very strong in a mathematical background, and they're looking to get a quick credential or an associate's degree to go enter the workforce and get a higher paying job than they would have when they were in high school. We also have students who want to transfer somewhere. They want to save some money. They want to end up at CMU or Pitt. So they're coming to our programs ready to take calculus. They're ready. They did great in high school, or maybe they're a high level algebra trig kind of student, and they're really looking for that transfer opportunity. What we've done is we've created a series of programs, and I'll let my colleague, Professor Thompson, talk about this a little bit more, where when you're interested in a topic, you're not necessarily tied to a track. So if we get students who are interested in robotics, we'll meet them wherever their ability level is in terms of their background in math and science, right? If they're ready to, take a fast track to Carnegie Mellon, they can get that hands-on robotics training while they're taking our engineering science degree, right? Which is that it can get that robotics focus, but it has calculus, it has calculus-based physics, it has circuits. They're ready to go to transfer into an ABET accredited program. Maybe they're interested in robotics, but calculus is not on the agenda, especially to start. They can get an engineering technology degree where they still get that hands-on robotics training, but with transferable algebra credits. So if they want to get a degree in business or engineering technology at another four-year institution, they can transfer over and still get that hands-on robotics experience. And then maybe we have a student who's interested in not much math at all, right? They hate math, they have no math background, they don't want to do it. They can do mechatronics where they'll still get that hands-on experience with robots, but they'll take math for the trades. So there's options for everyone along the way. So where a student is not going to preclude them from getting interested or getting that experience with robots. And we find that things like data analytics and robotics are in demand in the skilled trades now. I just had a class of students come through taking data analytics sponsored by Train, right? HVAC, right? Imagine that. Your Train guy comes to fix your air conditioner. He pulls up a Tableau dashboard, right? That's kind of weird, but that's where we are now, right? These skills are in demand no matter where students are going in the workforce. So this is sort of an example of the different paths students could take through our program. Professor Thompson put together a really great guide to current options. So Trish, if you want to jump in.
Sure. Just the way our programs are set up is you can start with basic certificates, and those generally will take about a year to complete. There are a few that are less than a year, but you can start with the certificate level. And then if you choose, at that point, you can either go into the workforce or continue on to get the associate degree. And then after the associate degree, we do have a couple programs that are designed to transfer to a four-year degree. So this basically shows you kind of based on what your math level is, what your interest is, how you can progress through and earn several different credentials along the way. And even at any point, you can divert from the, you can actually go out into the workforce and then return at some point and just keep going. So it doesn't kind of put any boundaries on your education. So you can continue on up through a PhD, really.
Yeah, I mean, that's it, right? So just personal sharing, I started at CCAC a million years ago, right? I transferred to a four-year school and got my engineering degree, eventually foolishly went on to get my doctorate. And here we are, right? So anything is the option for students today. I don't regret my doctorate. It was just a fun experience. But my wife was like, how much would it cost to get you to go back to grad school? And I think, oh my God, never. I was so miserable. So, I mean, no matter what students want to do, there's these options, right? If they want to spend 2 years with us and transfer, we've got programs for that. If they want to spend 2 years with us and get a great job, we've got programs for that. If they're a little pressed for time and they only want to stay 6 to 12 months, we got programs for that, and they're all stackable credentials. So if you get your civil engineering certificate and you come back after working for a while, it feeds into the degree. If you get your electronic certificate, it feeds into the degree, mechatronic, and so on and so forth. So we really try and value our students' time as much as possible. So here we are with, secondary educators. And people always think, they say, well, what am I going to do after college? Maybe I'll think about CCAC when I graduate. And one of the reasons we're so excited about talking today is that you don't have to wait until after college, right? High school students can be at CCAC while they're in high school. Because of the pandemic, so many of our classes are on Zoom and Blackboard, meaning a student doesn't have to worry about transportation to South Campus or West Hills if they want to jump into a course. If they want to save some time and money when they transfer later, or they're just a high achiever in high school, or they want to start getting college credit, they can do it right now, right? My personal story, why I started at CCAC before I went to University of Virginia, is I knew I was going to be working during school. And because I had my associates, I was able to get a much better job while I was working to earn my bachelor's. So a lot of our students really value that, because juggling work and family is a big responsibility. And we see these stories all the time, right? Students are graduating from high school and college in the same month. As CBS Pittsburgh, I actually don't think this was our student, but maybe it was. But it's not uncommon. So if you have students who are looking for an extra challenge, they want something to do, email us, email myself, email Professor Thompson. We can suggest courses that would be great for an interested student to enroll in. And there's always that fear of, high school students swimming with the big fish at college. Our high school students are the best in the class, right? The ones who are going above and beyond, coming to CCAC. I mean, they just knock it out of the park every time. And it's a great experience for our traditional students and the kids as well. So if there's anything we can do to encourage collaboration with you guys, we are all in. So some things we've done in the past, we've had educators reach out and encourage their students to enroll at CCAC. We've hosted field trips where a school will bring a bus out to CCAC for a day. COVID should be gone in the fall, right? So we could do this maybe and use the lab equipment and get some hands-on experience, right? You have a science class who really wants to use some robots. Come on, let's use robots for a day. We'd love to have you. If you want to teach a CCAC class in your school and award credit, we have a program where we can certify you to offer our own college coursework, right? We have a wonderful relationship with West Allegheny where they offer some of our intro mechatronics courses. If you're doing something interesting with robots, reach out to us. There might be a way that crosswalks into credit that could be a fun experience. If you're doing VEX at your school already, the Robotics Academy at CMU has this smart micro-credential series. We articulate that, and we're happy to give credit for those experiences. I mean, at the bottom, it's your idea. If you have some way in which you think we could work together to do something great for students, please let us know. We're open, we're excited. The way we get students in our programs is by working with them early and building that interest. We don't want someone to be, halfway through majoring in economics at some four-year school, wishing they got some experience with robots. Let's get them the experience now. Let's get them some college credit. Let's build a pathway for success in the future. That's the idea. There's just a couple other things I want to talk about, just one briefly, and then I'll kind of jump to the end and see if there's any questions. So we have some really innovative things we've been working on with the local workforce. We have some apprenticeship and training programs. And these are really cool. And Trish and I are going to present about this. I mean, Trish is doing all the work presenting at a conference next month, where we're basically working to copy the model of what some schools in Europe do for technical training, right? So if you go to Germany and you graduate high school and you want to get technical skills, you don't take time off from work to go to a community college and then get a job. There's this wonderful relationship that you have with an employer called an apprenticeship program, where when you graduate high school, you'll interview with a bunch of employers. You'll pick the one that's right for you, and you'll get a real job offer, and you'll start working right out of high school. But you also learn, because that employer will send you to school 1 or 2 days a week, and they'll pay for you to continue your vocational training, right? That's huge, because the trade schools and the two-year institutions in Germany work very closely with the employers to cultivate training that's the right fit. We just started doing this in Pittsburgh, of all places, right? Working with the German American Chamber of Commerce, German companies with offices in Pittsburgh are hiring high school students as soon as they graduate because they see the potential. They give those high school students great jobs, and they pay for those students to come to CCAC 1 day a week to take their classes. So they'll work Monday through Thursday, they'll come to CCAC on Friday, they'll take their classes, and we work so closely with the companies to make sure the labs are relevant for what they're doing. It's fantastic. Then they graduate from CCAC and they get a raise with their employer. It's just a wonderful cycle of learning that we're so excited to be a part of. So if you have a student who you know is saying, I don't want to go to college, I don't believe in college, but you think they grow up a little bit in a couple years, talk to us about our apprenticeship programs. Getting them working and having the employer sort of guide them through school is something we really don't do a good job of here in America. And for our students, it's made all the difference in the world, right? I have students who say, I never would have gone to school if I didn't do this program. And now I'm really enjoying it. And so our apprenticeship program gets students that certificate in mechatronics, and now our CAD technology program and engineering technologies. And so the program will pay for them to get their certificate. And we have students staying on voluntarily to get their associate's degree because they're having such a good time learning, right? I did not expect that to happen. I thought when they're done with school, they're going to be done. But it just shows it's one of those models that's really interesting. So like I said, I have some things in here for slides. If you're interested in learning more about our apprenticeship programs, the material will be available. You can ask questions. And then we've also worked closely with schools to make new programs. So we work real closely with Commonwealth Charter Academy, right? They're one of those cyber charter schools. They have a big facility on the waterfront. They moved into the old Macy's, and charter school, everyone's online, so they get to have this flagship program. They came to us and said, hey, we really want our students, when they finish their high school career with us, to have a credential that goes beyond that. So we worked with them, right? We said, if you can get us enough students to enroll, we can put together a certificate program where they'll get college credit from us and some employer recognized credentials out there. So we worked very closely with them to put together this Foundations of Robotics program. And the program's really relevant to them. I'm not saying let's do this with all of you. I'm saying if you have big dreams, let's talk about it. We're happy to kind of make that happen. So we stitched together 1, 2, 3, 4, 5 classes that they offer on site. We do some of them remotely. At the end of the day, their high school graduates get 6 industry certifications, 15 college credits. They're ready to get out there and do something cool, whether or not they go on to CCAC, right? They get this certificate at the same time they graduate high school. And it's just an example of some of the things we're working on. So I'm just rambling about, we get excited about collaborating with high school. If you have any questions at all, our emails are up there. Again, I'm Justin, my colleague Patricia. I mean, we really love collaborating with secondary educators. If there's anything we can do to spread the gospel of STEM, please don't hesitate to reach out. We'd love to work with you. We'd love to get creative. And thank you so much for having us today.
Thank you, Justin. Thank you, Trish. I'm going to turn it over to Bill to facilitate the question session.
All right, well, thank you very much. I had just the cheat sheet. I don't know if I should put it up or just look off my iPad. Might just be easier to do the iPad. So just a real brief. So I mentioned before, TEEP. TEEP is the Technology Education and Engineering Association of Pennsylvania. It was formed in 1952. And the purpose was primarily to promote technology in the trades and all. Back in 1952, it formed out of the Pennsylvania Vocational Association, and it morphed into the Industrial Arts Association back in when they first formed. In 1986, it turned into the Technology Education Association of Pennsylvania, TEEP with one E, and then recently here in the 2000s, we added the extra E for the engineering because that's been becoming a larger part of things. Now, our purpose is improving instruction across the state in technology and engineering education, keeping instructional content and improving that, methods and facilities to keep everything up to date and to have everything, state of the art, as close as we can get, for our schools. So everybody is on the same page as to where things should be, technology wise. So things like this webinar, usually in over the last 70 years, TEEP has had a conference, and it's been in like Harrisburg, and the last few they've been in Lancaster, but the idea has been to have these state conferences each year, to have teachers present, university professors present, and to have the the newest and greatest on lessons, safety in the classroom, new tools and materials, recently lasers and the robots and all of the things like that, 3D printers. You always see the state of the art, new tools that are coming out. So that was always the big thing, was the conference. And with COVID, the last 2 years, conference was changed into a virtual conference. And this year we're not having one, but we're pushing more webinars for that very reason. But the idea to build a community and to have a support system, to build the conference for the future, recognition of teachers and programs. We have awards we have a journal, the TEEP journal. So if you become a member, you get the TEEP journal quarterly. So if you're a teacher and you write an article, you can get an award for having the best journal article for the year. We have the Program of Excellence Awards, Teacher Awards, and you also have lesson plans, curriculum development, and all that, like, built into the support system, so that as a teacher coming out, if your principal comes to you and says, hey, we're changing it up next year, you're teaching CAD, or you're going to be teaching some other area that you're not familiar with, you can go to the TEEP resources and you can hit up some of the other teachers who might be working in that area, and you could then be a little bit more comfortable walking into the door of your classroom that day, first day of school, with a new subject. So that's primarily what TEEP is and what it's for. So we are looking to build members because the membership runs the the whole thing. So if we don't have the members, we don't have the people doing the work. We don't know, the more members we have, the better off the association is, and the more power. Recently, state standards in technology were coming out, and TEEP and TEEP leadership had a lot to do with what was going into those standards. So those are the types of things that the TEEP is there for the membership to help promote technology and to help them to help the membership, and so they can do their job better. So I did have a few questions that people had sent to me, and it was basic stuff like what are some of the other webinars that we'd be doing, and what are some of the other things that TEEP can do for us. And like I said, the big thing TEEP can do is support the membership through best practices and the conference and these webinars and things like that. Some of the questions related to what other webinars are going to be available. And on the TEEP website, if you go to teep.org, you can see that they have a webinar page, and I don't have that up right now. But on that webinar page, it has a list of all the future upcoming webinars, and you can register for those at the TEEP website. Some of them do have a fee if you're a non-member. If you are a member of TEEP, they're all free. So if you join in membership for TEEP, yeah, Rachel just put that in. Thank you. It's in the chat if anybody's looking. The membership's only $50 a year, and with that you get the journal, you get the access to the webinars and conference and all. So I know Melinda Fowler's on here on the call too today, and she is the chairperson for our Melinda, help me out.
Strategic Planning Committee.
Strategic Planning Committee. That's I know it's SPC, and I keep forgetting what it is. But we're on that. We are currently working hard to develop a plan for the next 5 years for what TEEP is going to look like, because like I said, we're trying to improve the membership. We're trying to reach out and really better assist all of the members. So do you have anything you want to say related to the SBC?
I guess the biggest thing I want to say is, as an organization, as a whole in the past, I think our biggest focus had been don't fix what isn't broken, right? And I feel like a lot of things had always been run that way, especially in Pennsylvania, right? It's a very big cultural thing in Pennsylvania. But as an organization, we're seeing a really big shift to what can we do better, and how can we make this better for everyone. And we just had a board meeting, I want to say last weekend, 2 weekends ago. And we spent probably an hour just talking about all of the really exciting things that we had brainstormed about, ways to make membership better for everybody, not just for those of us that are active. And I would say that in the past, those of us that are active are pretty much board members. We may have about 200 members in TEEP, but I can only name off those of us that are on the board. So I'm really excited about that. And I'm not just saying that because it's partially my job, but because we have a lot more buy-in from those people on the outside of the board, helping to come up with those ideas as well.
I think one of the things, a lot of what we've been doing, I think with webinars, at least recently, a lot of things in technology education, I feel like it seems like robotics is the big thing that's out there now, because it does encompass so many aspects. You have computer programming, computer science, you've got the math, you've got physics, you've got the machining and hands-on aspect of it. So it does cover so much of what technology education is their base. But I had a friend of mine he teaches graphics, and he said, well, he goes, I don't know if I'm that interested in all the robotics stuff. And I said, well, that's fine. We have a lot of other things we need, help with, and things that we want to work on as a membership. And so it's like, developing our website and developing advertisements and developing these webinars and putting stuff together like that. It's like that's where like the graphics people really they come in and they can support the association, but then they can also share those ideas because myself, graphics was never one of my bigger areas, and so using some software, finding out what software is the best out there to use for something related to graphics for design. I don't know what that is offhand. So it's like having those resources, being able to call that friend up and having that community. That's really where it helps to have the membership and to know the people and to see what everybody's doing. So I think that's the underlying goal for the next several years of TEEP is to establish that the groundwork and the foundation for the next 5 years here to really have that network of people and the resources on through the website so we can access each other and access this information. So I don't know, questions from anybody here that needs to know something more about TEEP or ideas for what we could be doing, because that's been our big discussion is what's the next thing we're going to do. So what could we do to help you?
Bill and Melinda, I just wanted to comment that we really appreciate all the groundwork that you're doing. You're opening up doors. You're on the front line. You're there and playing a really pivotal role in opening up opportunities for students across Pennsylvania in the tech ed space and letting them know what possibilities are out there and raising awareness of the different job opportunities and the careers that are going to be there. So you're in a really pivotal role, and we're delighted to join you and share from our perspective. And I know that our colleagues at CCAC had so many exciting things as well. There's just an opportunity, and I see lots of possibilities for collaboration and getting those 200 teachers pumped up and connected into some of those opportunities. Amazing. So thank you for the foundation that you're laying and the hard work and to build those opportunities. We appreciate that.
Thank you. I like to say, I know I have like my school district, Central Valley, we're right down the road from CCAC West. And I know I've had a couple of kids go to the mechatronics program and come out of that, and parents love it. The kids loved it. It was a great opportunity for them. And it's been good having it so close to home. So we have to look at getting some more kids down there.
Yeah, we're ready. I mean, Trish built that program, right? It's her baby. So we're so glad to hear that it's been so good for you guys.
Yeah, it's heard nothing but good things about it. So it's great job with everything you've been doing over there.
I'm on the other side of the state. I'm in Shippensburg. So I'm excited that this is available because I would have not heard about it otherwise. But we just started robotics. This will be our second year having robotics in our high school. I've been begging. It took a lot of begging. So I'm excited to have this as a groundwork to work off of to build my program with. So I appreciate the work that you've done as well to give me something to work from, so I don't have to start from scratch.
There's a lot of opportunity, and I don't know, like the Robot Doctor, the Pioneers program that I was involved with, that too, that I thought that really helped, and I was dragging my math teachers into to that because it's always working as a tech ed teacher. I was the kid that I didn't understand why I was learning math. I was doing the odd problems on page 35, and I didn't understand why. And I kept on asking the question, where am I going to use this information? And my math teacher never really gave me an answer for that. And now as a tech ed teacher, I stumble across 1,000,001 reasons where I need to use math. And I keep thinking, I wish that I paid more attention in that class. So I'm always pestering my math teachers. And when I got involved with that Pioneers program, I went banging on their door again. And I said, hey, I found another program, guys, and this is it's got a lot of math in it, and it incorporates robotics. It'd be great to work on, something in conjunction. So if you haven't done it yet, looking at the Robot Doctor and that content just as there's the 8 lessons, but you could take each one of those and expand it into multiple lessons for different things. So it's a great opportunity, I think, for if you're just getting into robotics and not quite sure where to head with it, that's a great place to start. Use it as a supplemental, you know. So
I'd like to comment. I incorporated the robot doctor into our intro to robotics class last summer because of COVID, but really found a lot of value in it. And actually, we used it with our German American students, and they were able to then go back to their places of work and see, well, how could we apply this at work? So it really worked out nice, and I think they enjoyed it as well as I did too. So.
that's great. In the German American Chamber of Commerce, the German Chamber of Commerce, I've heard about that a couple of times, and that apprenticeship program, it's like I keep looking into it, and it's looks great. So that's another great opportunity, I think, that's out there for us. So
they started with mechatronics, they expanded into CAD, they're doing technical sales engineering. I don't know where she finds the money, but she does. So we're not complaining. It's wonderful.
Yeah. It's a great thing. And these apprenticeships, that's more and more kids, I think, are going into apprenticeships, whether it's a trade union or whether it's through like the National Tooling Machining Association apprenticeship, something along those lines. But when they find out about them, especially the kids that I have in class, it's like, wait, I can get paid to go to school and work, and I get insurance, health insurance, and all that, and I don't. My buddies are going $50,000 in debt, and I can come out with money in my pocket. So it's an advantage. It's really good, and I think it's something that's advantageous for a lot of kids. So yeah, it's a great program. We'll keep plugging this away. So were there any other questions or comments related for TEEP or for anybody else involved here?
So this is a start of a conversation and continuation. I think that there were wonderful resources that were shared today, and it's so important. That apprenticeship program, when I learned about it as well, that's great. And the robot doctor and some of these, we've got to continue talking and sharing things out. We'll be reaching out to our colleagues at TEEP to share some of the information from CCAC and others, because each of us are trying to connect our students into opportunities, and I think together, by threading together some of these resources, and we'll have a lot to build on. So I want to thank Bill for co-hosting today and inviting us through TEEP, and Justin and Trish for sharing that wealth of information and programs that are dynamic from CCAC. We're excited to have that open call for collaboration, that opportunity for everyone, and for Max for sharing his expertise, and the work with the robot doctor was really a wonderful opportunity. So we look forward to connecting with many of you, and this will be shared on the TEEP website, and we'll have some follow-up conversations. And our next conversation will be directly with some of the students that are doing research. So, what is needed to enter the field of robotics, and what were some of their foundational coursework and experiences in high school and along their journey. So looking forward to that. Thank you everyone for your time and for the collaboration.
Thank you, Rachel.